The development of analog to digital converter technology has been driven by requirements for high performance, high reliability, and low cost. This chart projects the converter requirements for the 1980s as established by the United States Air Force, ranging from 16 bits at 2 megahertz to 6 bits at 1 gigahertz. The Advanced Circuit Technology Laboratory has responded by developing state-of-the-art analog to digital converters using custom monolithic integrated circuits. That technology began with the 4-bit quantizer chip. The quantizer is the basic analog to digital converter and a building block which allows conversion of 4 bits of data in one integrated circuit. In 1976, the first 4-bit quantizer chip was developed, having a sample rate of 420 megasamples per second, or 420 million samples of data in 1 second. Its input bandwidth is 250 megahertz, or 250 million cycles in 1 second, with a power dissipation of 1.8 watts. Its dimensions are 121 by 123 mils. The development of the 4-bit quantizer chip led to the design of the F-18 analog to digital converter module during 1977 and 1978. Using 9 hybrids, the module could simultaneously sample 4 video channels and encode each to 12-bit resolution. The 3-pass architecture used 6 4-bit quantizers, operated at approximately a 6.3 megahertz conversion rate, and dissipated 57 watts. In 1979, a high-resolution 6-bit encoder was developed. This encoder operates at a sample rate of 250 megasamples per second with an input bandwidth of 125 megahertz and dissipates 8.5 watts. This encoder is capable of simultaneously converting 80,000 audio channels into digital information. The next application of the 4-bit quantizer chip was during 1979 and 1980. A 10-bit converter was developed using 6 4-bit quantizer chips. Operating with full 10-bit resolution, the converter encodes at 60 megahertz. At this rate, the entire King James Version of the Bible could be converted into 60 different languages in 1 second. As a result of the success of the 4-bit quantizer chip, development on a 5-bit quantizer chip began in 1979. It was designed to sample up to 500 megasamples per second with an input bandwidth of 250 megahertz. Power dissipation, 2.2 watts. Size, 109 by 132 mils. The state-of-the-art in 1983 is the 6-bit encoder implemented with one 6-bit quantizer chip. The chip operates at 500 megasamples per second with an input bandwidth of 250 megahertz. It dissipates less than 6 watts of power with a physical size of 180 by 200 mils. This chip replaces the equivalent circuitry of 4 4-bit quantizers, including the reference generation circuitry that previously occupied 1/2 the area of the 6-bit encoder hybrid. Also in 1983, the prototype 12-bit analog to digital converter was completed using 3 monolithic integrated circuits designed by the Radar Systems Group. These custom integrated circuits allowed for a new architecture, the feedback conversion scheme. This scheme eliminated a large amount of the hardware and simplified the conversion process. The new F-15 MISIP analog signal processor contains the same architecture. In order to fully capitalize on the cost and performance advantages of the new integrated circuit capabilities, an entire analog signal processor will eventually contain 14 custom integrated circuits and 20 gate arrays. In fact, the entire converter will be contained in a single 1 by 2.3 inch hybrid package. In the next several years, the analog to digital converter will be further integrated into a single integrated circuit component. Today, the Advanced Circuit Technology Laboratory is developing approximately 50 custom integrated circuits. Each is directed at improving performance and reliability while reducing the cost, power, and weight of all hardware produced by the Radar Systems Group.